Hi all, this is Lakshmi working as Assistant Professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on applications of smart sensors and devices. And the topic here I'm going to discuss is smart MEMS sensors with AI. So we all know about the term MEMS. So MEMS means it is micro-electro-mechanical system. So here the smart MEMS sensor with AI will combine this MEMS, that is micro-electro-mechanical system, with the artificial intelligence in order to create intelligent, adaptive and self-learning sensing system. So these sensors not only measure physical parameters but also it analyze, interpret and act on data which is in local or in the cloud. So why these MEMS sensor makes smart means the traditional MEMS sensors they only sense and output the raw data, whereas the smart MEMS sensors will integrate the MEMS sensing element, the signal conditioning part, the ADC blocks, the embedded processes or the edge AI and the communication protocols, the power management, all these are embedded into this smart MEMS sensors. Hence, we call it as smart MEMS when compared with the traditional MEMS sensors. So with AI, these sensors can learn patterns, it can detect any defects or anomalies, and also can make the decisions. So now talking about the empathy part of this MEMS sensor. So we have to talk with respect to the in a perspective of the consumers, patients when we are talking about the healthcare industries, the end users, engineers and researchers, manufacturers and industries, healthcare professionals. So the patients who are using wearable health sensors or the drivers who are relying on vehicle safety system, the industrial operators monitoring the machines. For example, the engineers, we can talk about the MEMS designers, VLSI and embedded system engineers, AI model developers. So when we talk about empathy, we have to take into consideration all these end users and how these users feel and experience. So the users will expect accurate real-time sensing, and if any false alarm exists, frustration would be created, and people are concerned about the battery life and frequent recharging, and the safety crucial system should be accurate, and all these factors are to be taken for the empathy part. So the pain points will be like if the raw sensor data would be noisy, the continuous data transmission, manual calibration, late fault detection, and all these to be taken into consideration when we are designing a MEMS sensor. So, so how we can exactly define the MEMS sensor is, so they are the MEMS normally they are miniature devices that combine the mechanical and electrical components to detect the physical phenomena. So it converts these phenomenon into electrical signals for analysis. So there are different types like gyroscopes, pressure sensors, accelerometers, etc. So normally they are miniaturized component. So it is lightweight, compact, and it is cost effective, which enhances the performance and user experience. So integrating this AI with MEMS, that is, we go for a lot of AI algorithms, the data processing enhancement and the machine learning or deep learning algorithms helps us in achieving this. So certain things are to be done like pattern recognition, anomaly and fault detection, predictive analysis, self calibration, energy optimization, all these comes under these AI algorithms. So certain types of machine learning like the SVM or the neural networks like deep learning, convolutional neural networks, tiny ML, all these are useful in integrating this AI with MEMS. So the data processing enhancement, machine learning application, and the smart algorithms help us in achieving this goal. So applications in healthcare industry is firstly we can talk about the patient monitoring, wearable devices and telemedicine. So the MEM sensors when it is integrated along with the AI, it can continuously monitor the vital signs and it provides real-time health data to the healthcare providers. And wearable devices they are portable which is inbuilt. We can carry that with the human and we can track the physical activity also. Telemedicine means the doctor will be at one place and the patient will be at the other place. So through the advanced AI MEM sensors, so remote health monitoring is possible with the help of this application. So similar to healthcare, these MEMS plays a vital role in automotive industries also, like advanced driver assistance system make use of more of these MEMS in real-time monitoring. And for predictive maintenance, like in industry application, they are used to predict the vehicle component failures and etc. maintenance cost and also in autonomous vehicles. So the challenges is all about its miniaturization and power consumption, data security and interoperability. So the size, reducing the size of the component plays a vital role and the battery life and the make sure the data is transferred without any loss. So this is the overall mind map of the smart MEMS sensor system. So what is all about MEMS basics is micro-electro-mechanical system. So how it functions, the mechanical energy is converted into the electrical signals and the features of these smart MEMS sensors are calibration, diagnostics, noise reduction, etc. and the basic sensors element and the transduction mechanisms and power management and other communication protocols like I2C, SPI, UART and CAN are major communication protocols used. So today's assessment, which transduction mechanism is commonly used in MEMS pressure sensor? It is all about the piezo-resistive sensor. And what makes a MEMS sensor smart is the embedded signal processing and its self-diagnostics makes the MEMS sensor smart.